Hello, I'm Marion Santini. I work for the Regulatory Assistance Project. RAP is a non-profit organization. We are dedicated to accelerating the transition to a clean, reliable, and efficient energy future. Today, I'm going to talk about buildings and about the Energy Efficiency Directive. I will focus on Article 7, the energy savings obligation. I would like to discuss emerging trends in monitoring and verification and how they could support the EU's renovation objectives. First, let me start with some context. As you might know, the EU decided to increase its climate target for 2030. In this graph, you can see the emission cuts that the Commission expects in the residential and tertiary sectors. This means that we should accelerate action in the building sector now. It's really a challenge, especially given the low renovation rates we have right now in the EU. So last year, the Commission published a strategy called the Renovation Wave. The aim of the Renovation Wave is to double the renovation rate by 2030. The Renovation Wave lists a number of action points to do that. One suggestion is to make more use of pay-for-performance schemes. The interest in pay-for-performance schemes is actually growing in the EU. RAP is a partner of the Horizon 2020 project Sensei, which looks at developing these schemes in the EU. Sensei provides a definition of pay-for-performance, which you can see on this slide. So P4P schemes here are energy efficiency programs. They aim to deliver greater and more persistent energy savings. They compensate energy efficiency resources based on a comparison of measured energy consumption and modeled counterfactual energy consumption. So in other words, the energy consumption of the building is tracked over time, and payments are made either at the end of the measurement period or on an ongoing basis. In the EU, many energy efficiency programs rely on deemed savings calculations method. This means that the program manager makes assumptions about the savings associated with a particular intervention. Participants don't need to track energy consumption over time. They usually get a subsidy at the beginning of the project based on the equipment they have installed. What makes P4P schemes different is that they make use of energy metering equipment. The energy consumption of the building is tracked over time. This is often done with smart meters, but not systematically. The data is then compared to a baseline. The baseline shows how energy consumption would have evolved without the measure. And the payment is proportional to the amount of energy saved. According to Sensei, with deemed savings, there is an incentive to install as many equipment pieces as possible. This does not ensure high-quality installation and maintenance. On the opposite, with P4P schemes, there is an incentive to getting as many savings as possible. This should, in principle, result in more persistent savings. Let me give you an example. In California, PG&E, the utility, is subject to an energy savings obligation. They implement a share of this obligation with pay-for-performance arrangements. PG&E has selected aggregators to deliver savings in the residential sector. The aggregators are paid based on the energy savings delivered to their clients. These energy savings are calculated with method data using the Caltrack method. Aggregators receive monthly payments from PG&E during 2 years. That payment is proportional to the energy saved. In the EU, the main tool to drive energy efficiency program in member states is Article 7 of the EED. With this article, member states must trigger a certain amount of energy savings among end users. The savings should come from national policy measures like, for example, energy efficiency obligation schemes or subsidy schemes. Member states have to report on the impact of these policies to the Commission. The EED allows 4 methods for member states to calculate energy savings under Article 7. You can see this on the slide. Method savings in red is the only method which requires recording the actual reduction in energy use after the intervention. From what we can see in member states' reports, this method is mainly used in the industrial sector. It is not widely used in the building sector, and this is probably because it has been so far too costly to track energy consumption and to establish a baseline for each building. In Europe, several projects look at putting in place pay-for-performance schemes based on method savings. As I mentioned, RAP is involved with one of these initiatives, Sensei. With this paper, I wanted to summarize where the discussion is and discuss the potential of using method savings to support building policy. The paper describes what increased climate goals mean for EU buildings policy. It identifies synergies and trade-offs between Article 7 of the EED and renovation goals. Finally, the paper discusses prospects of using method savings in the context of Article 7 buildings programs. Article 7 of the EED is not limited to policies in the building sector. But as you can see in the yellow part of this graph, member states achieve an important share of Article 7 savings in buildings. Actually, many more savings probably take place in buildings when you take into account cross-cutting measures like energy efficiency obligation schemes. These measures are captured in the blue part of this graph. But in practice, the impact of Article 7 on the building sector is probably lower than what was expected by member states. First, many member states are not on track to achieve their obligations. Secondly, there are some issues related to the reliability of the savings estimates reported by member states. The question of the reliability of savings is relevant to our discussion. In the past few years, there's been developments in the field of energy savings measurement. This practice is called advanced monitoring and verification. With smart meters, you get much more granular information about energy consumption. At the same time, software is now available to deal with this large amount of data. This opens new perspective for method savings methods. Supporters of these methods argue that they can reduce M&V costs. Once everything is running, you need less input from engineers to account for savings for each project. In theory, these methods can provide finer estimates for energy savings compared to dim savings methodologies. They could apply to individual projects or to an aggregated number of smaller projects. In the residential sector, for example, portfolios of buildings are more stable and manageable than individual buildings. Another potential benefit is that advanced monitoring and verification can help the development of the aggregator model in the building sector. First, let's take the perspective of public authorities. As I mentioned earlier, they can deliver performance-based payments to aggregators, as it is done in the US. They can also decide to reward time and location-specific energy savings. This is also being tested in the US to deal with peak energy consumption. Let's now take the perspective of aggregators or energy services companies. It is difficult for these companies to work in the residential sector. One of the reasons is that you have high transaction costs there. Households have unstable baseline and you need a lot of expertise and site visits to understand what's going on in the building. Advanced monitoring and verification could reduce this cost. In addition, with more granular data, energy services companies have better insights of what's happening in the building. This can help them engage customers. In particular, they can reward behavioral and operational savings, which is not possible with dim savings methods. Different modeling algorithms and software tools are available. To advance this discussion, Sensei has developed an energy efficiency meter based on machine learning. The tool is available online and Sensei is looking for feedback from practitioners. Now, to use these methods in the context of Article 7, we should discuss a number of elements. This includes, for example, the confidence level expected from savings estimates. I listed some of these questions in the paper, and they would require a longer discussion. To conclude, I would say that advanced monitoring and verification could help public authorities in Europe increase certainty over the impact of energy efficiency policies. For the moment, this proposal is mainly theoretical, and a first step to validate this would be to look at the first evaluations coming from the US pilots and to also pilot these methods in the EU. In the paper, I did not discuss dimmed savings methods in detail. These methods present a number of benefits, but they put the performance risk on the public authority. We should therefore put more efforts to evaluate programs based on dim savings to increase certainty over energy savings estimates. Overall, further research will be needed to explore the costs and benefits of the dimmed and method savings approaches. Here we are. You can find contact information on this slide. I'd be very happy to follow up and hear your feedback and questions. Thank you.